Live streaming is on.
Okay, so hi all, we are here today to talk about the hardware part of the OpenInsulin project. So we will start by introducing yourself. So I'm Jan, I'm a protein biochemist trying to learn how to do more hardware stuff. And I'm working on building a protein purification system.
And I'm Anthony, one of the diabetics, one of the people with more of a software and control theory background. So I'm trying to see where I can help out with the electronics and that sort of thing with the equipment that we're making.
Anthony, do you want to explain why we are looking at doing hardware stuff?
Certainly.
Yeah. Okay.
Yeah. So as you, of course, know, we've gotten a lot of secondhand instruments from labs, academic labs and commercial labs that were getting rid of old equipment or winding down, and they had donated equipment to us through an organization called BioLink Depot, and we've gotten other donations occasionally as well. And even though the equipment that we need was available in this form, often we've had issues with the equipment being broken in some fairly trivial way, but it's just very difficult to repair because we don't really have any documentation of the design, and we don't necessarily know where to get the spare part that we need other than to try to find another machine that has a working instance of that part. And we've also had a lot of trouble with the control software for the equipment that we need. Is very hard to get a hold of at all without a very expensive support contract with the manufacturer, and often the software is very brittle and not very reliable. It will require a certain old operating system to be installed on your computer, or require very particular hardware configuration, and it really doesn't reach anywhere near the modern standard for software reliability. So in the meantime, we've been working with open source equipment in the form of like OpenPCR for our PCR needs, and Opentrons, which is an open source lab robot. And we've seen that making open hardware can solve all of these problems at once. And we decided that that would be a good way to make insulin production as economical and as accessible as it can possibly be. Should be to make the hardware that we need to do protein production and purification open source as well. So in order to do that, there are basically two main components. One is the bioreactor, which is where you grow the culture that produces the protein. And then there's the chromatography system, which does the purification. And you still need a few other things like a centrifuge maybe, and there's some other components to the whole system, but those are a lot easier to come by than these two pieces. So we decided to focus on these, and they're fairly simple when it comes down to it. The bioreactor is very similar to a beer brewing setup in that it has like a stainless steel or a glass vessel, and it has a way of measuring and controlling the temperature and the pH and the oxygenation and other things that are important to establish the right growing conditions for a culture. And the purification system is, for the most part, a bunch of plumbing and valves and pumps, but there's also one part that's a little tricky, which is the UV detector, which is how you actually detect your protein coming out the end of it. So that is part that Jan and some other folks have been focusing on recently, because it's kind of the bottleneck to everything. And I've just recently started to look at the electronics a little bit and see if I can contribute a little bit there. So Jan, maybe you can explain a little bit more about what's going on.
Yeah, I want to add also that the logic, the rationale for looking at hardware is also because in a lot of places it would be really complicated to have access to equipment to produce to do bioreactor and the chromatography system. And commercially, those devices are really, really expensive. So it would be, even if we have a protocol to share, to produce and purify insulin, if you can't have access to those equipment, then you will be quite limited to the amount of insulin that you can produce. So it's economically, like you said, it makes sense for us. If we really want to widespread the access to insulin, to also look at this aspect of the issue. I will talk now about what we did for the chromatography system we try to build. So I have it here. It's on my left is the prototype. So basically, So basically, the idea is to use Creality Industry 3D printer and modifying it to be a chromatography system. So I will try to not move too much, but on the back, I will try to show it. Okay. So this thing here is one member of the team designed a peristaltic pump that you can use using the extruder motor, and instead using it to pump liquid. So this you have I just put it's a glass of water, but you can imagine it's the solution where your protein is, insulin is. Then you pump it with this. There is another member who work on a mixing chamber. So normally when you have a chromatography purification system, you want to be able to have different buffer to do your purification. So you have to have a system to mix solution together. I will not go too much into the detail, but basically you need also a valve system. So we are also working on that. Then it goes to a column where you have this one is empty, and normally you have the resin you use to that the protein will bind to it. So the protein will bind to your resin, and all the molecule will be washed out. And then it goes to what Anthony was describing, the UV system that we are working on. So this would be the box where you have the UV, and the liquid will go through this kind of cuvette. And then you will have, normally the idea is you have the UV light going on the side, and then the sensor going here, so we can follow in real time the amount of protein going through. So it has to be deep UV 280 nanometer because it's the wavelengths you use to measure protein. And then when we measure that it's the protein we want going out of the column, basically we want to be able to get the fraction with the protein, so we can use the X and Y axis of the 3D printer to collect the fraction. So the tubing will go here, and then it would move above the fraction collector, and we can collect the fraction with our protein. And all of this can be controlled with Raspberry Pi and Arduinos. So it's the gist of the project. I will. Anthony?
Yes.
Do you have something to add?
Well, we've been talking a little bit about the UV sensor part of it. So I was interested in, since that's kind of the bottleneck part of it, like how that works, and what open questions we have on how to build that part.
Yeah, the UV part of it was the most complicated one, because you had to use really dangerous, expensive bulb. I would say something silly, but I think it was mostly argon lamp or mercury lamp. I don't remember. And basically, you need filter to remove the wrong wavelengths, and then you have the good wavelengths and so on. And this part was really complicated, but there is a lot of improvement nowadays with the deep UV LEDs. So you can expect now to have something working with the UV LEDs, and they are way less expensive. So it's I think part of the fact that it would be possible now, it's because the technology also improved a lot in that regard. And in my knowledge, also the professional chromatography system also switched to LEDs, and they are not using lamp anymore. So yeah, it's where we are right now.
Yeah, and so for that part, you're just going to have an LED, the light UV light source, and it'll shine through that cuvette, and then you have a photo detector that measure how much was actually transmitted, and that tells you by how much was absorbed what the concentration of protein is at that time when that fraction is flowing through it, right?
Yeah, basically the LED looks something like that, and so they are deep UV, so they are pretty dangerous for you. Basically, what will happen if you expose yourself to this light, then you will have creation of defect in your DNA, and then if you have too much defect, then your repair system can't keep it up, and then you might have cancer. So you still have to be careful when you play around with those, but yeah, it's they are not costing too much. We still have a lot of question about the sensitivity of it and if it would be really usable for protein measurement. But you can imagine also trying to build a system when you have multiple and kind of increasing the light by just increasing the amount of it. But it's a bit more work. Yeah, I will check if we have question. I don't think we do, or maybe it's not. Wait, can I? No, I don't think we have question. I forgot to mention that we forgot one step, that we also need one module which will be to measure the conductivity in the solution, and we have another member also working on that. So basically, the conductivity will give you an idea about the amount of salt in the solution. Oh. And I don't think we have questions. I forgot to mention that Okay, so sorry.
You're on the loop.
Issue. Yeah. Yeah, and the conductivity, it's important for some chromatography, typically ion exchange, because you can do the different step of your purification with a different concentration of salt, basically. And this is the one we use for the purification of insulin, so it would be really good to have it. So yeah, I forgot to mention this one. Typically, it would be just after the UV chamber.
And for that, you can just put like some metal plates in the flow of the fluid or something and measure.
Yeah, they are based in just a cathode and cathode anode kind of system. I think, if I'm not saying, yeah, I think it's that. And then you kind of measure the differential between two times. So you have 2 points basically, and then you look at the current going through those 2 points, and then you can estimate the conductivity. There is other conductivity system that kind of, you don't need the probe inside the solution, but you can look at the I think the magnetism. I don't know. I will say stuff. It's beyond my knowledge in that, but yeah.
Oh yeah, that's interesting. Maybe it uses some sort of an inductive coupling to the.
Yeah,
fluid.
and I wanted to look at it because it seems easier to work with, but I don't think it's I think it's way more complicated actually, because you use a AC current and you look at what you have of the, I don't know, it's, yeah.
Oh yeah, well, send me a link because I think I could probably figure that out. That's,
Yeah, I can send you a link.
Use my electrical engineering training from college and so.
Yeah, I mean, there is also a question of sensitivity, and it might not be in the range on what is useful. But yeah, I can send you a link and you can look at it. Yeah.
Yeah, interesting.
Do you plan to develop a software? How automatized it would be? It's a good question. I don't know. You want to answer to that?
Well, for just general open source chromatography, there are already open source packages like OpenChrome. And I think once we get the hardware to the point where it works, then it would make sense to put an interface on it that would be able to interface with the existing software for chromatography.
Yeah.
For the bioreactor, I'm actually not aware of there being like a kind of open source package for that already, but it's really just simple control problems that it's solving. So it seems like once you made the embedded system and put some data logging in it, you'd be done, and there isn't a whole lot of a role for like an open source standalone package that's device independent for that. But I actually would make sure to check around to see if there isn't anything that someone has done there.
I mean, for the insulin, if we think about the insulin, the ideal system would be one which is the most automatized possible. So from the bioreactor to the end product, you can imagine to have something where it kind of do everything automatically. There is some bottleneck, like removing the yeast, for example, to have something without big particle to not clog the system. It's one of the issue in this kind of automatized system, which can be done, but it's in a open source way with the equipment we have. It could be tricky, but yeah, automatization could be interesting for insulin, the virtual project. But if we just think about the protein chromatography system, I like the idea that it's still it's versatile enough that it can be used for something else than insulin, and it can also be used for protein chromatography for other things than insulin. But yeah, it's complicated, and I think there is value to look at that. But I think we can also do both at the same time. How would you check for the pressure in the column? Yeah, we need to add a pressure module in it also, which can be done.
As far as I can tell, those are commodity sensors, but I haven't looked at the specifics yet.
Yeah, you in the modern protein chromatography system, usually they have the pressure of the whole system, and then you have the pressure for the column. So I don't know exactly how they do that. I have to look at it, to be honest.
Well, you're going to have like a pressure drop across the column, right? Because it's resisting the fluid flow.
Yeah, so I don't know if they add two pressure sensor, and they I don't know how they do that.
That seems like the way to do it, yeah.
But for the one we are doing right now, it will be low pressure chromatography. So the pressure sensor basically is the tubing who just pop out if there is too much pressure, because we'll just use the lure lock kind of system tubing. So those are not really can't contact too much pressure. So the tubing will just jump before anything bad can happen to the system. If we want to have a higher pressure system, we have to change the whole tubing connecting stuff, which could be an issue because my understanding is some of it is still patented. So then designing your own connecting kind of stuff, it's a bit complicated.
Yeah, well, for protein, you don't really work at high pressures, right?
I mean, the higher the pressure, the best resolution you have usually. So you kind of want to increase the pressure if you can, but if you can't increase, and if you increase the pressure, I think you can also no, if you have a higher flow, you have actually a lower pressure. Yeah. So yeah, I mean, there is consideration with the flow and how much the speed you can reach and stuff like that. If you have a higher, okay, this I should look at, but yeah, no, if you increase the flow, you will have higher pressure. Now I'm saying this stuff. So also it could be an advantage to have a system which can take more pressure, because then you can be faster, I think. Yeah, if you have higher column, you have lower pressure. Something like that. How many people work on this project? On the hardware team specifically, I think we are, I mean, including you, we are 8. I hope I don't forget anybody. But yeah, I think we are 8 right now. And the interesting part is people are working remotely, so they can design on their own. They can design one module we need for the chromatography, and then I can try to build it myself and then include in the system. So there's a lot of, and also for the software part, you can write it on your side and then just implement it to the project. So there is a lot of flexibility. If anybody wants to join, that they can collaborate, but not even if they can't go on site, basically. Yeah.
Yeah, and we have the calls at 11:30 Pacific Sunday, right?
Yes, every Sunday for the hardware team. If people are interested, it would be at 11:30 Pacific time. Yeah. Yeah, I don't think we have more questions. I think the last one was, are you looking for volunteers? And we are always looking for volunteers, so it's a yes. So if you want, you can join on Sunday. We also have a meeting on Wednesday at 6 p.m. Pacific time, I think.
Yeah. For new members, I think the Sunday meeting is
It's
a
better.
little better because we have more time.
Yes,
but either one is all right.
Okay, I think I don't have anything else to add. Do you have something you want to add?
I would just emphasize how great it would be to have some more people help out. So if you're interested, we're looking forward to hearing from you.
Yeah, and we are looking for any type of skills for hardware, which could be the software part, more engineer part, and we are looking for about everything. Okay. Thanks, Anthony.
Thanks, yeah.
And I will see you tomorrow for the meeting.
Yep. Until then.
See you.